Howdy and welcome to Life Science. Scientists discover huge heat-emitting blob on the far side of the moon. One day ago, scientists detected a peculiar blob of heat-emitting material buried on the far side of the moon. The most likely culprit is a rock that is very rare outside of Earth. Yeah, these are rather round craters, quite likely made electrically. A map of the moon's far side taken by NASA's Gravity Recovery and Interior Laboratory mission. Recent observations of the moon's far side revealed a strange heat anomaly that could be a long dead volcano. Scientists have discovered an anomalous blob of heat on the far side of the moon. This mysterious hotspot has a strange origin. It's likely caused by the natural radiation emanating from a huge buried mass of granite, which is rarely found in large quantities outside of Earth, according to new research. Yeah, I don't know how many planets and moons they have been they had checked until now, but there are quite a few outside, like outside of our solar system too. But anyway, on the moon, a dead volcano that hasn't erupted for 3.5 billion years is likely the source of this unusual hunk of granite. So they assume that the moon has been there since 3.5 billion years, which is quite likely wrong. There is more Earth-like. This is more Earth-like than we had imagined can be produced on the moon, which lacks the water and plate tectonics to help granites form on Earth. Lead study author Matt Ziegler on the Planetary Science Institute of Tucson, Arizona, said in a statement. Ziegler and his colleague Rita Economos of Southern Methodist University discovered the heat with a new method using microwaves to measure subsurface temperatures via the Chinese lunar orbiters Chang'e 1 and 2. They also used data from NASA's Lunar Prospector and Lunar Reconnaissance orbiters. What they found was an area about 31 miles across where the temperature is about 18 degrees Fahrenheit, warmer than the surroundings. This region was below 12.4-mile diameter spot on the surface that is rich in silicon and that is thought to be a collapsed volcanic crater. The dead volcano last erupted 3.5 billion years ago, but magma from its plumbing system is likely still sitting below the surface, giving off radiation. This find is a 50-kilometer wide batholith. A batholith is a type of volcanic rock that forms when lava rises to the Earth's crust but does not erupt onto the surface. Economos said in a statement, El Capitan and Half Dome in Yosemite in California are examples of similar granite rocks which have risen to the surface. El Capitan is a vertical rock formation in Yosemite National Park on the north side of Yosemite Valley near its western end. The granite monolith is about 3,000 feet from base to summit along its tallest face and is a world-famous location for big wall climbing, including the disciplines of aid climbing, free climbing, and more recently, for free solo climbing. Maybe this has been created electrically too. But I will leave a link below, you can check it out. This is how it looks. El Capitan. The researchers reported their initial findings in the journal Nature on July 5th and presented additional details on July 12th at the Goldschmidt Conference in Geochemistry in Lyon, France. The findings are incredibly interesting, Stefan M. Elardo, a chemist at the University of Florida, was not involved in the study, said in the statement. Granite is extremely common on Earth, but not elsewhere in the solar system, added Elardo. People don't think twice about having a granite countertop in their kitchen, he said. But geologically speaking, it's quite hard to make granite without water and plate tectonics, which is why we really don't see that type of rock on other planets. So if this finding by Siegler and colleagues holds up, it's going to be massively important for how we think about the internal workings of other rocky bodies in the solar system. Yeah, I was just about to say something like this about the tail of the moon. So let me draw something. Here is the moon, and that's Earth, and the moon has this kind of tail, and there could be some kind of a backfiring action towards the moon, which could heat the thing up there on the other side electrically, like microwaves or other things like that. This is just one possibility, that it would be somehow from the tail of the moon would reflect back on to the moon. But now let me show you still something about the granite and stuff like that. And for this we have to go quickly around at my mountain water paper, a new approach to mountain forming, volcanism, glaciers, and the role of water in an electric environment. We go down to page 90 of the journal, which is still not here. So now let's start just somewhere. Let's just start here. It accumulated by strong magnetic fields and fused into pelletoids in situ during the process. The layer of oolitic iron ore might have been created in a rather short amount of time, maybe in minutes, and not millions of years like common theory uses to explain. Yeah, obviously this is about iron oolitic ore, but just let's go on. The heat created during the event also accelerated the process of cementing of the fossils. The discharge event penetrated the Earth's surface deep below. It might have excavated sediments and or pulled magma from deeper depth closer to the surface. This might explain the high geothermal potential of Central Europe. The process of cementation was quite likely also accelerated through the heat rising from underneath. In the Jura and Alps region are many mining operations which excavate the raw materials for the production of cement. Comparing the compositions of the most common rocks in the Alps and Jura, such as limestone, dolomite, marble, and granite. Yeah, we were just talking about granite on the moon. We will notice similarities. Limestone, dolomite, and marble are mainly made out of calcite, calcium, and chalk, where granite seems to differ because it has a fairly large amount of silica. Limestone is considered a sedimentary rock. Dolomite is defined as sedimentary carbonate rock. Marble is metamorphic, and granite is an igneous rock. How could those different kinds of rocks possibly belong together? Granite has a high content of silica, but it's mainly made out of feldspar, which, on the other hand, is mainly made out of calcium. I think all these rocks are basically the same type of rock in different stages of transmutation with different amounts of impurities. It depends on the amount of heat, pressure, voltage, etc. applied on the rock formations present at the moment of electrical discharge events, and how many times a similar event has taken place in the past, i.e. recurrent transmutation of elements. The number of metals in the rocks, manganese, aluminium, iron, etc., fits also very good into this point of view. Elements transmutate into something else, and their magnetic properties also change during the transmutation. This means that the Alps and the Jura are the same type of rock. The Jura is just much less transmutated because it might have been covered in water, whilst the Alps, which are much more elevated, got much more altered because they weren't continuously cooled with water and they therefore burned. That's why I think they are also so much darker. In some places, the material didn't stick together firmly to create a solid rock. This is where there are more piles of gravel in different size than a solid rock, and in these places occur often landslides and rock falls. So, my point is basically that the granite on the moon is probably just electrically altered feldspar. Maybe I have to scroll down because I'm searching for a picture. Wait a second. Because here, picture number 12, or figure number 12, comparison of an arc discharge event on the sun on the left, solar flare, and a theoretical counterpart on Earth. The form and shape of the discharge would match the scars on the surface of Earth's crust. So there is this arc which goes from one place to another, and here in the center we have basically the eruption where we have CMEs and solar flares erupting. And here on the other side, I probably should draw. This would be the arc. Let me use another color. And this would be the rings we just saw. And here at the center we have the Alps. And they would get risen upwards, as is mainly going on in the sun as well at the same spot. And since this is basically, in a way, the center of the whole activity, the energy available could be rather high. The heat, the pressures, and all of these kinds of things. And maybe, or quite likely, Moon has experienced some rather strong discharge events in the past. It's probably born through a discharge event with, or when there has been planetary encounters. So there could be quite likely something on the other side of the moon, which is still warm. Maybe it gets fed all the time by some magnetic fields or some lines of energy or reflecting from this tail of the moon, which reflects back on the moon, and there's some kind of electromagnetic heating going on there continuously. Yeah. But there is just one possibility of how there is granite on the moon. It got formed by electrical discharge events. And it all starts like calcium, limestone. And if you go down the whole rabbit hole, we could make it like that. Let's just scroll down until the very end of the paper. These are all the references. You can check them out. And that's the addendum substitute. And here, number 3. Niagara Crystal Caves in Mexico. Poas Volcano, Costa Rica. Possible hydrogen emissions related to cryptodome activities. Conclusion. So that's the conclusion of the very last part of the whole paper. Maybe the hydrogen anion is the white rabbit. Through its negative charge and great abundance, it could be the root and source of all alkalinity. And if granite is really just an electrically altered alkaline rock, then hydrogen plays a big role in that. Because it's the root and source of all alkalinity. The reason for why the white rivers are white and why Earth is a blue marble. Earth's surface has a net negative charge, as earlier shown with Thornhill's repellent core, so it might be not a coincidence that hydrogen accumulates on the surface and makes life on Earth possible. In a Birkeland current, hydrogen and oxygen are also found on the outer side. Yes, very interesting. You can read something about the moon and you can bring it back on Earth and you find the same things. Probably the same mechanisms have been playing a role on the moon as well, as they quite likely have done on Earth. But anyway, I think I leave it here. I don't know if you could follow that, but you can read the paper and check this stuff out and think about it. It's not that I will present like total, complete explanations for all this stuff. I just try to present things I found, some thoughts about them, and hope that they are getting thought further. Until maybe one day we really understand how stuff works. This would be very amazing. Very amazing. But anyway, thank you. Bye.